All right, so working with voltage, we may have to measure voltage. And do some related analysis of circuits. So a really simple circuit, like we've seen so many times before, might be this one with a couple of cells in series to make a battery, a load like a light bulb, and we should really get some more exotic loads, but a light bulb. And you told me before, how do you connect a voltmeter? Series or parallel? Series. A voltmeter. It was a 50-50 shot, guys. In parallel, because what we're effectively doing is finding a difference in electric potential energy, and that's why they call it potential difference. That's the delta E, the difference part, and the electric potential is the E over Q part. So we're finding the electric potential difference between the energy per charge on one side compared to the other side. It's really a comparison, subtraction, right? In any case, we're finding the voltage. We know that if we're finding voltage, we're finding change in energy per charge. So here's a scenario. Now, do you actually make the measurements this way? Likely not. You likely actually just make a voltage measurement with a multimeter, but I'm going to give you some values in this scenario that are hypotheticals. Okay? So hypothetically, if I knew that a 12-volt battery, so that would make this guy a 12-volt battery, 12-volt battery supplies some sum of charges. Let's make it be 1.0 times 10 to the power of 3 coulombs, 1,000 coulombs, to the starter motor. And the people that are the auto people know about a starter motor. I know it's a lot. Maybe it's a big number. Let's see if that makes sense. Maybe it's not enough. Oh, I'm sorry. M. I'm sorry. I had my story already thought out, and I drew too simple a circuit. Let's make an M for motor. Okay? That is the symbol for motor. Just an M in a circle, if you remember from grade 9. But an M in a circle, a motor, is going to receive 1,000 coulombs due to a 12-volt battery. Is 12 volts a realistic charge for a battery in a car?
Yeah.
What's a realistic voltage on a battery in a car?
900.
I don't know the answer myself. I'm not an auto guy, and I haven't looked at a car battery. Don't make up silly numbers. Well, let's go with 12 volts. I was kind of thinking that was realistic. Oh no, size of a battery, size doesn't matter. Ask any auto mechanic. All right, a 12-volt battery supplies... Shh. I'll wait for the sharpening to be done. A 12-volt... No. We're going to finish the problem. A 12-volt battery supplies a 1.0 times 10 to the power of 3 coulomb charge to the starter motor of a car. And what I would like to know is what the change in energy per coulomb is. What's that? You don't have to do a calculation. That's the voltage, 12 volts. The next thing I'd like to know is how many coulombs have we got? A lot. Can I figure out how much energy is required to start this motor? What's the formula? Oh, yeah, this is doable. Okay. We could say that it's 12 volts times 1,000 coulombs over 1.0 times 10 to the power of 3 to really highlight the number of sig figs is 2. 12 times 1,000, can you do it? 12,000, or we could say 1.2 times 10 to the power of 4 joules. And we know that it's going to be joules because volts really are made up of joules per coulomb, so the coulombs cancel out. Boom, boom, and you're really just left with joules in the end. So the units do always work out. Now what I would like to figure out is if for the same circuit, if the starter runs for, oh, what do you think? 2 seconds? Let's say 2 seconds. 2.0 seconds. What could I figure out? Could I figure out the current? What current is flowing? What is the current that's flowing? Yeah, what is the amperage? What is the current that's flowing? What is the current flow? What is the amperage? What's the I value? How could I get the current based on what I know? Yeah?
Q over delta T.
Okay, I could go straight to Q over delta T. That is equal to current. Is there another way I could get there based on even some calculated values? This is a nice clean way to do it. What's another formula that involves energy maybe in current? Yeah, we could say delta E is equal to V times I times delta T. Now this in practice is probably the one you'd be more likely to use because you can actually use a multimeter to measure all these values, or this value and this value. You could actually measure the current directly, but for the sake of this kind of cooked up problem, we'll do it this way. I want to use this problem, or this formula just for practice. So I could say delta E over V times delta T, because I'd have to divide both sides by V and both sides by delta T to get I by itself is equal to I. I'd say that I is equal to, we previously found that it's 1.2 times 10 to the power of 4 joules divided by 12 volts times delta T. Now the delta T we said was going to be 2 seconds, 2.0 seconds. So I predict this is going to be something like 5 times 10 to the power of something, but let's figure out what it is. 1.2 times 10 to the power of 4 is 12,000. 12,000 divided by 12 is 1,000. Okay, 1,000 divided by 2 is 500. Check it out in your calculator. Let's see what you get. Did you get 500? Yeah?
I got
500, okay. So we could say that it's 500, or we could say, if we want to really illustrate the sig figs, we could say that it's 5.0 times 10 to the power of 2 amps, or coulombs per second, because we know that this guy here is going to have its units canceling out with the volts, so that we are left with only coulombs, and then we have seconds on the bottom. Coulombs per second, the amps.